Welcome to Zaption Tour 4.1, using graphs to relate two quantities. Okay, the essential idea here is basically this. We can use graphs to visually represent the relationship between two variable quantities as they both change. Now, I'm pretty sure you have a pretty good understanding of what graphs are, but we really want to have a deep understanding of the fact that two things are changing at once and how we can relate those two things. So there's 7 boxes, so let's get into the first box here. Okay, first box, number 1, is an example. It says the graph shows the volume of air in a balloon as you blow it up. And the picture is over here, and this makes sense, okay? It says, what are the variables? Well, the variables are the two things that we are relating to each other. So the variables are time versus volume. So those are my two variables, time versus volume. Time represents basically the x-axis, volume represents the y-axis. So you'll notice at time 0 there is no volume in the balloon. And then we blow a little bit of air and it gets some volume. And then look what happens here, right? It levels off. That's because we're taking an inhale and we're not putting any volume in or any air into the balloon, so no volume would go up. Then we blow again, and then we inhale, and then we blow again, then we let go. And then what do you think happens right about here when all of a sudden at this moment in time all the air goes out of the balloon? Yes, you probably guessed it right. That's where the balloon pops and all of the volume releases from the balloon. So we can have a graph of time versus volume. This is an example of how we use graph to relate two variables that are changing. Here's box number 2. It's another example. The graph over here shows time and length, and the title of the graph says board length. So the question says, what are the variables in the following graph? And then describe how the variables are related at various points in the graph. Okay, well, the variables, you probably guessed, are time versus length. That's easy enough. And at time 0, my board is a certain length, right? And it stays this length until this moment in time. And at that moment in time, its length now decreases to here. Why do you suppose that is? Well, that's because we've cut the board, right? And then at this particular moment in time, our length decreases to here. So we've cut the board again. And then at this moment in time, our length of the board decreases down to this, where it stays constant because we do no more cuts. So that is a graph of time versus the length of a board, and the parts that I have knocked off here are when we are actually cutting the board. Hopefully that makes some sense to you. Box number 3 is a you try. It says, what are the variables in the following graph? So you're going to answer that, and then describe how the variables are related at various points on the graph. Okay, I want everyone to sort of see the answer to this one. I'm pretty sure you got the variables right. You probably said minutes of the call to the cost, and those would be the two variables. And the description that I came up with was, well, I know that the cost of the call remains constant until a certain point, and then the cost of the call increases after that. So hopefully you wrote something like that. Box number 4 is an example in which we have data from a table, and we want to connect that data to a graph on the right. So the directions say which graph could represent the data shown in the table. Okay, so the two variables that I would be comparing would be days to total downloads. Okay, so notice that each graph has days on the x-axis and total downloads on the y-axis. So what do we notice here, right? At day 1 I have 346 downloads. At day 2 I have 1011. That's quite a bit more than 346. At day 3 I've got 3455, and then I have a big spike at day 4 at 10,000. So I know right away that it cannot be option D. How do I know that right away? Well, because this graph goes down, right? And that's not what my data is telling me. My data is telling me that as the days goes on, the downloads increase. So I know for a fact it's not D. Okay, so that leaves either A, B, or C. Well, I also know for a fact that it's not A. The reason I know that's not A is because each of these increments are increasing by a constant value, right? Constant, this increment here is the same. Basically, the slope of these little dots each one of these little increments is the same, and I know that that's not the true because the difference between these 2 days is not the same as the difference between those 2 days. So I know right away it's not A either. So it has to be B or it has to be C. Alright, I'm sure you figured it out. The right answer is B. The reason the right answer is B is because in between day 3 and day 4, I have a very large spike, okay? Meaning that I have grown this amount of total downloads in between day 3 and day 4. That's not what C is suggesting. Day 3 and day 4 has a very tiny spike, so it wouldn't be C. So the correct answer would be B. Box 5 is another you try. Same kind of example. The table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table below? I'll let you think about that and answer their question. Well, hopefully you picked the right answer, and the right answer in this case is C. Okay, how do we know this? Well, look at the difference between which they're going down, right? After 0 hours, I have 5. After 1 hour, I have 4.8. That's a difference of 0.2. Then I have from 4.8 to 4.6. That's another difference of 0.2. And then I have from 4.4 to, or 4.6 to 4.4. That's another difference of 0.2. So the way in which this graph is going down is constant. The difference is 0.2 each time. So that automatically eliminates B, because look, this is a curve, right? So it's not that one. So that leaves either A or C. Well, how do I know it's not A? Because this is suggesting that after the 4th use, I would have a 0 amount of sunscreen left, whereas in this case, the 4th entry, I still have 4.4 ounces left. Therefore, the correct answer has to be C. Box number 6, we're going to practice sketching a graph. Okay, so let's read this together. It says rocketry. A model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during its flight? Label each section, okay? I'm going to let you guys go ahead and try this one first, and then I will show you the answer. So see if you can come up with your own sketch. Okay, hopefully you have a pretty good sketch. Take a look at this sketch. Well, this is actually a really good picture, but we'll just pretend it's my sketch. So the variables that I am comparing are time versus the height of the rocket. So it says that the model rocket rises quickly. So this is representing the rising quickly part until it slows to a stop, meaning that the fuel has run out and it can't rise anymore. That would be this point right here. It stops rising. After that, it falls quickly because it's falling back down to the earth. And then it says a parachute opens. So that means that the rate at which the parachute is falling back to the earth has slowed down from falling quickly down to a slow fall all the way until it reaches the earth again over here at some time t. Okay, last box, we're going to practice again. It says, suppose you start to swing yourself on a playground swing. You move back and forth and swing higher in the air. Then you slowly swing to a stop. What sketch of a graph could represent how your height from the ground might change over time? Label each section. Okay, I want you to think about this first before I show you what mine's going to do. What are the variables and what's your sketch going to look like? Okay, I'm curious to see if you came up with something that I came up with. How high you are from the ground. Hopefully you got the variables time versus height correct. And so when you sit on the swing, you're about, I'm going to say you're about this high off the ground. Then when you start moving back and forth, right, you begin to oscillate a little bit. So this is you just swinging back and forth. And then it says you get higher and higher. So your height is going to increase a little bit. Notice though, I'm never actually going below the lowest point that I have, but I do get higher and higher. And then I eventually slow down again until I'm just sitting on the swing, and that's what it looked like there. I can show you a cool video of this later too. Remind me to show it to you in class. Hopefully you got that one right.